Question number 9 is going to look a lot like questions 7 and 8. And I say they're going to look a lot like because the structure of many of these questions does end up looking exactly like number 7 and number 8 if you look a little bit lower in the question, but also because the steps and the processes are going to look a lot like it. To the point where you might even be able to devise some shortcuts for yourself because you might start to say, hey, wait a minute, I'm starting to see some repetition here. And that's great. Remember, we rarely in algebra end up doing problems the long way 100% of the time. I mean, think back to when you first learned algebra, like probably in middle school. Most people were very diligent about showing all their steps and showing every single detail, and then got to the point where they'd done problems so many times that they started just skipping some steps or doing some steps in their head. And it was totally fine to do that. By now, nobody's nitpicking about your ability to show every single step in basic equations because we know that you know how to do them and we know that you feel confident with the repetition. The same thing goes here. If you get to the point where it's repetitive and you can just do these in your head or without writing everything down, that's great. Don't worry about showing work. Just make sure that what you're doing makes sense. So in question letter A, let's make sure that we follow the steps that we established in the previous set of examples. First, we're going to introduce or write a log on both sides of the problem. The problem is currently exponential, which is where I want to start. So I'm going to start by saying log of 3 to the x equals log of 24. Log on both sides. Wonderful. Now, second step, use the power property to bring x down as a multiplication so that x can come down to the front, and I'll have x times log 3 equals log 24 unchanged. This is good because now x is multiplying something. And now my algebra kicks in so I can say, hey, wait, this is a multiplication. I know how to get rid of multiplication. I'm just going to divide. Anything that multiplies, you can divide to get rid of it. So I'll divide to get rid of log 3. That means x is by itself now, and I have an answer of log 24 over log 3. That is what we call an exact answer. And at the AP level, we actually say it's totally fine to leave your answer like that. Sometimes people ask you to also change it to a decimal. In this question, it says to represent your answer as a fraction with logs and as a decimal. So in that little box after the squiggly equal sign, which means approximately, it is expected that we would have used our calculator to convert that to a number. Log 24 divided by log 3 is 2.893 if I round to 3 decimal places. And now I can ask myself, well, does that make sense? Well, if I look at it, 3 to the power of 2 would have been 9, too small. 3 to the power of 3 would have been 27, too big. So it does make sense that I got an answer between power of 2 and power of 3. And it does help to have that security in our answer to know that it wasn't just a coincidence. If you've already started to say, hey, Herbert, hold on, wait a minute, I've noticed something here, I've noticed a pattern, that's good. If you're starting to notice something, see if that pattern continues, because I'm going to do a couple more examples just to start to get that repetition built up. I'll do letter D next, just because vertically it's all kind of aligned here. 14 to the power of x equals 9, same steps. Introduce or write a log on both sides. So I'll have log of 14 to the power of x equals log of 9. Now this problem has a log in it, so I can use the power property, bring x down as a multiplication. Down it goes to the front, so x times log 14 equals log 9. Now it's a multiplication, so I can get x by itself. If x is multiplying, I can divide to get x by itself, same as always. And then, since x is by itself, I have my fraction now, which is considered to be part of your answer. You can just write it exactly as you see it, log 9 over log 14. And I will convert that to a decimal using my calculator by just typing it in exactly the way I see it. Log 9, close the parentheses, divided by log 14, close the parentheses. That gives me an answer of 0.833 if I round it carefully. 0.833. This answer is a little bit more surprising, but I guess it does make sense, because 14 to the power of 0 would be 1. That's too small. 14 to the power of 1 would be 14, which is too big. So it does stand to reason that x had to be between 0 and 1. And again, if you're not sure, or if you're just conceptually like, what? Did that make sense? Check it out. 14 to the power of 0.83, and I can keep typing, 257,93277. There's actually a copy and paste feature too, but I'm just showing this for the sake of illustration. 8.9, that's really close to 9, and that's what you wanted. So it does work, even though it might have been a sort of unexpected number, 0 point something. It'll even work for letter G, because in letter G, even though it looks like a different sort of problem, we can just as easily rewrite the problem as 7 to the power of x equals 40. And now all of a sudden it looks just like all the other problems that we've been doing, to the point where we can use the exact same steps. First step, introduce or write a log on both sides. So log of 7 to the x equals log of 40. Check. Now I can use the power property to bring x down as a multiplication. X times log 7 equals log 40. And now I can say to myself, okay, well, x is multiplying log 7. How do I get rid of it? I'll divide log 7. That will cancel out the multiplication, leaving x by itself. And now I have my fraction once again. Log 40 over log 7. If I type that into my calculator, log 40 divided by log 7, I get 1.896 if I round to 3 decimal places, 1.896, and that again makes sense, because 7 to the power of 1 is 7, which is too small, 7 to the power of 2 is 49, which is too big, so I was expecting an answer between 1 and 2, and that's exactly what I got. So hopefully by now you've seen the pattern. If by now you're looking at this going, wait a minute, Herbert, hold on. I'm seeing how these numbers go together. I don't know if I need to show all these steps. I think I can just write the fraction. That's great. If you've gotten to the point where you can just write the fraction because you see the numbers and you see a relationship there, then don't show any work. Just write all your answers and type them all into the calculator. Convert them to decimals. That works totally fine. Decide what works best for you. But either way, try to finish up question number 9. Question number 10 and question number 11 was something that in theory could have been a direction we could take this power property if we had more time to roll with it. But considering the circumstances of this year, and considering that right now we're just looking at logs as an introduction to get you ready for next year, I don't think those questions are super essential. You'll notice in the learning plan I didn't even have you bother with questions 10 and 11, so don't worry about those. Just get yourself comfortable with number 9, and then once you feel comfortable with number 9, consider yourself good to go. Even at number 9, it's probably worth noting there are a couple of questions that are a bit of a challenge. Letter E and letter F are a little bit tricky, only because they have a little extra something going on. The 2 in letter E needs to be moved to the other side before you even start the log process, and the 1 needs to be moved in letter F before you even start the log process. That's one of those kind of tricky things to just be aware of, but if it bothers you, you can skip those questions as well and just focus on B, C, H, and I, because they all look similar and they all end up being pretty much aligned with the examples that we did. So again, this is all about getting the basics. You don't have to challenge yourself right now unless you want to. And if you want to challenge yourself, the answer key is available. You can definitely figure it out and work backwards if you have to. But don't consider those important problems at all.